Hi, in reference to this research paper, I have made videos on the analysis performed. Now today I will principal component analysis. The principal component analysis is used to extract the weights. So first of all, we will have to transform the data, or simply we will have to normalize the data. For the normalization, we have two criteria: higher the better and lower the better. These are the formulas for the composite desirability method as obvious from the title of the research paper. So you will have to transform the data of the signal to noise ratio that I showed you in the previous video. For this is computation, normalization of the data. Put that normalized data in the Minitab or SPSS. So I have put the data for RA, RQ till the draws. Now you will have to click on stat. After the stat, go to multivariate, principal components. In the principal components, select from RA to draws, select all of them. After that, click on OK. You can click on the graph, but I think there is no need of it. However, if you click on the scree plot, the scree plot will tell you the importance of all of the variables. Then click OK, so you will get the result. So you can see it here that this table has the results similar to the published results, 0.484 and 0.446. Since the percentage contribution of PC1 is 66.4%, that's too much high. So we will select the eigenvectors associated with the PC1. So we'll copy all of these eigenvectors and paste them here in the Excel. After that, you can see here one of the eigenvector is negative. So in order to extract the weights, we will have to take scale of each result. So it is C27. So you can see it here, the weights are extracted by C27 scale. Likewise till C32. So here we will get all of the weights. Now these weights will be multiplied with the composite desirability data. How we get that data? I told you earlier, with the help of the two equations for larger the better and smaller the better. After the multiplication, I got weighted CDF, weighted composite desirability function values. These weighted values will be then averaged out to check out that which of the setting has the highest weight. We'll go again to the Excel. So you can see it here. These are the composite desirability method and here is the weight extreme. Now how you will calculate the weighted CDF? Now 0.411, that is the RA, surface roughness, it will be multiplied by its respective weight that has been given in the P6. So you can see it here that J6 will be multiplied with the P6, J6, P6. Then in this way, the whole column of the RA will be multiplied with the weight of RA. So you can see it here, if I come down in this column, so all of the cells has been multiplied with the P6. Similarly, if we talk about this second one resembles with the data of RQ. So here 0.395 or K6 has been multiplied with the P7. So you can see it here, K6 has been multiplied by P7 and the whole column V has been multiplied with the P7. Similarly, this last column, the draws, it's O6. O6 will be multiplied by P11. So now if we check here that O6 multiplied by P11 and this whole column has been multiplied by with the weight of the draws. So similarly, we got weighted CDF. Now following the expression as shown in equation 6 in my research paper, we will now find the overall desirability DI for each of the treatment, and this result has been shown in the table number 8 and in the second column. How we will do it? In the Excel, you will have to multiply all of these cells and you will get the overall desirability result for all of the treatments. Here you can see the maximum result has been achieved with the last treatment. So I applied a formula of ranking. So ranking formula can be applied very easily. If you click here, so I selected rank is equal to R6. R6 is the first. So R6 is the first value of the desirability function, desirability value that has been obtained, comma R6 till R14. So you can see it here, the formula that I have applied. So R14, it's the last cell and R6 till R22. So in this way, the weights has been ranked. So we can see that the treatment number 9 has the highest desirability value, so it is found to be optimum.